Next we have Dmitry Eremin. He's going to talk with us about Lustre client I/O parallelization. And he's in the support development team of high performance data division at Intel. And he's primarily focused on adoption of Lustre for new Intel hardware like Xeon Phi and Omnipath. Dmitry, thanks.
Thank you. Hello everyone. Today I'd like to talk about the Lustre client I/O performance. First of all, I'd like to show the current I/O performance, then analyze the internals, data flow, how we process I/O internally, show flow graphs of this process. Then I will talk about ideas how to improve this, and finally you will see the result of this work. So, in current era of multi-core systems, the number of cores in client machines is constantly increased, but single-threaded I/O is still common. Unfortunately, the new cores in multi-core system, the frequency of each core in new multi-core systems significantly dropped down, and this mostly affects the single-threaded performance on new systems. For example, the Intel Omnipath fabric intensively use the host CPU for packet processing, and this prevents to use the network bandwidth in full speed. So it can saturate the full network. Also, the memory transfer operation on this system pretty slow, and this also significantly affects. Also, we have an additional issue when the read-ahead algorithm blocks the user space I/O operation for whole time of read-ahead. So we need other solution for this, rather than adding more compute nodes. For my experience, I use the following hardware. So I take a regular Xeon and a new system with Xeon Phi processor. As you can see on this slide, the difference in frequency of those cores about twice. But at the same time, the difference in count of cores also about twice. So let's look how this system will behave. This is a client system, and use Omnipath fabric as interconnect. So I use I/O performance tool to measure results, and current Lustre it's about pre-2.10 version shows me the following results. So I'd like to pay your attention on the red box here, where we see the lowest performance results. So it's related to single thread and two threads. Just remind those numbers. I will try to improve exactly the numbers from this box. On Xeon Phi system, the performance behaves pretty the same, but much worse. And again, the numbers for single-threaded I/O is very low. And this is significant impact on for customers. Let's try to analyze what happens inside the Lustre client when the user calls the write operation. So the whole buffer of user data split for the page size, and for each page size we allocate a new page in the kernel page cache, then copy the data from user space to this new allocated page, and then submit this page into RPC queue. This is done in the loop until all buffer will be uploaded into kernel page cache. Then we wake up portal RPC thread, which submit this request to the servers and wait when the data will be filled, will be passed to the server, and the operations is complete. After that, we resume the user operations, and it continues do other stuff. So let's look how much time we spend in each operations. So this is the flow graph of only write operation. So you can see that about half of all time we spent by page cache allocations. The other significant part of time we spend for submitting pages into RPC queue. And only a small portion of this time is dedicated for copy user data. Let's look what happens inside the read operation. It's pretty the same as the write operation, but with little difference. So here we have a read ahead operation which tries to prefetch data in ahead of usage and load more data which really was requested by user. And again, we start with page cache allocation, so we request new page from page cache. Then we submit this list of pages into RPC queue, wake up portal RPC layer, and wait when the data will be filled from server. After all data is now in our client side, we copy this data to user space and return control to user. And again, this is a flow graph of read operation. And again, the half of all read time, they spend in read ahead functionality. And most of time of read ahead, again, we spend for page cache allocation. So this is a pretty expensive operation. This part we submit pages into RPC queue, and again, only a small portion is spent for copy user data. So when I look on those pictures, I try to think about what we can do to improve this situation, especially, as I mentioned before, for systems with slow cores which cannot provide enough execution rate for these serial operations. So the idea is straightforward. So first of all, we can try to split the time-consuming operations into several threads. This allows us to make page cache allocations in parallel. Also submit pages into several RPC in parallel, and copy user data also in parallel. The experiment shows that this is very important for Xeon Phi system, just because the memory transfer operation on this system is terribly slow. Also, the next idea is try to move a read-ahead operation into the separate asynchronous thread to avoid the blocking of user space, of user operations, and resume the main user thread as soon as possible, as soon as first data will be available for user. This allows us to avoid the cost of unused reads in case of false read ahead. When we use the several threads, it will be very beneficial to utilize more portal RPC threads to process network operations again in parallel. This also should significantly improve this situation. And the latest improvement was already implemented is try to use multiple network connections and balance the traffic between them. This is especially important for OmniPath Fabric, which also intensively use the host CPU for packet processing, and one core cannot saturate the whole bandwidth of this card. For this purpose, I introduce a new parallel tasks API, which allows to execute in parallel on multiple CPUs simple tasks. It uses a system thread pool instead of creating new one, which we have in Lustre right now a lot. This API provides the ordered and disordered task completion. This is very helpful to write the code and get the correct completion. So far, I implement only around submission tasks in round-robin fashion. And related to multiple endpoints, now Lustre uses a single network channel between nodes. And this is a real limitation for OmniPath Fabric right now. We did some optimization in network layer LND driver, and now we can use multiple endpoints and balance the traffic between them. For more details, you can look at this ticket number. After this work was done, I again tried to measure performance, and first of all, I get the flame graph of new read operations. So right now, you can see the picture is much different, and the part of the half of time of all read operations now is spent in user copy data. This doesn't mean that the whole time of copy data became more. The absolute time the same as it was before, but in this case we don't do any additional work and do mostly only work which required for complete this operation. But anyway, still we need to initialize read ahead and first page cache allocation. Also, you can see on this graph. All work what was in the same thread before, now in asynchronous parallel read ahead thread. And you can see that all operations what was before now executed asynchronously and don't block the user thread. So now let's see the performance numbers of those work. So first of all, again, I measure on Xeon system and got the following results. So I have several tunables here, and I'd like to pay attention that on this slide I showed the picture when the parallel I/O really was turned off, but asynchronous read ahead thread is used for optimization. So the light green and light blue lines show you the original performance of current Lustre, but dark green and dark light lines show the new performance of patched client. So because of parallel I/O is turned off, you mostly don't see any performance improvements for write operation, but read operations, as you can see, improved, and mostly for single-threaded I/O. Then I turn on parallelization, and again read ahead is asynchronously. So in this case, I have improvement of write operation, but I have some performance degradation because of overhead of this parallelization work. The next slide showed that the impact of multiple connections which I turn on for this measurement. And this provides significant performance increase for read operations, especially for many threads. And also this helps significantly increase the read for single thread. Unfortunately, the stability of these improvements is not quite well, but again, it's really behave better. For Xeon Phi systems, the picture is not so good, but anyway, as you can see, the main focus of my work was to improve single-threaded performance, and this performance was significantly improved, at least twice. And again, first of all, parallelization is off, and only asynchronous thread with read ahead helps significantly improve read operation. When I turn on parallelization, I got the very good performance improvements for Xeon Phi systems. Unfortunately, multiply Q pairs don't makes significant effect on the Phi system. I don't understand so far why this happens. Actually, we should have this impact, but the results show that this is not helps us significantly. But anyway, as you can see, the single thread performance significantly increased. And finally, I tried to launch the real-world application. I use the hybrid coordination model application for this and try to see how this application will behave. Unfortunately, this application don't use the file I/O intensively, at least in the workload I used, so the impact was not so significant. But anyway, I observed that the numbers, performance numbers, the time spent for original run with current Lustre and the patched version, the numbers is better. So real-world application became benefit from this work. So this work really work for real-world applications. So finally, using parallel I/O and multiple connections for network, this work allows us to utilize the multi-core system, especially for single-threaded applications. And now the applications behave much more better on this. Also, the system with OmniPath Fabric will get benefits from this work. And using asynchronous thread, Lustre now doesn't block the user space thread, and read operation became better. From performance numbers I just showed, you can see that on some workloads, up to twice speed up for read-write operations was observed. The final, I'd like to say that the write work already landed to 2.10 Lustre. The read operation need to be improved, and I hope it will be landed in next maintenance release of 2.10. So I'm done and ready for questions.
Questions for Dmitry? Rob, you're all over it.
I'm on it this time.
Hi. The Xeon Phi, was it the socket version or the card version?
Sorry?
Was the Xeon Phi, was it the version for the socket, or was it an accelerator card?
It was a version of the socket, not the card. It's not the card.
Then did you pin the processors? Did you make a process pin close to the memory controller, which also holds the page pool?
I'm sorry, I don't understand. So this was just the regular system when the one CPU, for example, Xeon CPU, was replaced by the new KNL CPU, Xeon Phi CPU. So the system mostly the same.
There are 4 memory controllers in contrast, and maybe you have to go with a complete network of the complete processor.
No.
This is
it's just regular system and the network controller on the same motherboard. So it's I have, for Xeon Phi, we have only one socket, so we don't have multiple sockets. Or I don't understand you.
Let's discuss this offline. I think so. As far as I know, the Xeon Phi has 4 memory controllers, right?
Memory
That's
controller
right.
inside the chip.
So, and if you place a job in the wrong corner of your Xeon Phi, for every request, you have to traverse over the complete processor to reach the right memory controller, to reach the right memory. So this delays your complete, and this may vary with every time you start your experiment.
Okay, I propose to talk about this offline just because maybe I don't understand something.
Okay, no problem.
Anybody else?